This is our 114, 115 comparing data sets notes. So the first thing that you're going to do is you're going to find the mean and the median of the data set and then find it with the outlier removed. So luckily the numbers are in order. So remember how we find the mean? We just need to add up all of our numbers. So 17 plus 19 plus 21 plus 32 plus 46 plus 48 plus 50 plus 107. So I take that, which is 340, and then I divide by 2, 4, 6, 8, divide by 8. So 42.5. The median, big or small, big, small, big, small, big. Take them, add them together, and divide by 2. So the median is 39. Okay. Now remember, when you have an outlier, which one's more accurate, the mean or the median? You know the mean is, or the median is more accurate. Now let's find the mean without the outlier. So I'm going to take 340 and subtract 107 because that's my outlier. And divide by 1, 2, 3, 4, 5, 6, 7. Divide by 7. So my mean is now 33.3. And the median without the outlier. Small, big, small, big, small, big. There's the median. Now notice your mean and your median are very, very close to each other because there's no outliers. And that's kind of good. We want to look for that. All right, so here we go. A person wants to join the local bowling league and brings a histogram of his last several games to prove that he is good enough. What is the typical bowling score? Now, on a histogram, remember, how do we find that typical score? We look for the largest column. So that would be here to here. So that is 80 to 90, or 80 to 100. I know it's hard to see, but that's okay. That's my typical score. Why is the mean score so different than the typical value? Remember, why is this mean so much different? Well, there's some outliers up here. He's got some good scores. You have some outliers which affect the mean. Okay. They don't really affect that typical value, but they definitely affect the mean. Okay, now which is more accurate for him? The typical score or the mean? So the mean is about right here. It's about right there. 10, 20, 30, 40, 50. Yep, there's the mean. Okay. Which one's more typical? So I would say, which one do you think is more typical? Do we think it's right here or right here? Well, it's really close. I would go either way on this one because that is very close to this large hump. So I would say either one would be close, but probably your typical. Okay. What does the standard deviation mean? Now, we have a very large standard deviation. Remember from yesterday, large standard deviation means you have your data scattered everywhere and you have some outliers, then you're pretty far away from your mean. So you have data points scattered and far from the mean. Okay. So in terms of the data, a smaller standard deviation means about what about how consistently he bowls somewhere near. So smaller standard deviation means he's going to have more values around that mean score, around that 140. But since my standard deviation is so high, we have them scattered all over creation. So F, bowling scores can be anywhere from 0 to 300, with higher points meaning a better score. But most bowling games are between 190 and 210. So 190 and 210 is from here to here. That's where most of them are. Is he a good bowler? So let's really look. Where is most of his data? Most of his data is skewed right. Most of his data is to the left. So I would probably say he's not that great of a bowler because he has data that far. Okay?